if we take the square root of x and then add on the square root of x and then add on the square root of x and then do this infinitely different many times. And then we're going to multiply this by 3 and then to get 15. We have to find the value of x. Well, I'm not sure what to do with this, all these square roots. Well, I wish I know about the times 3 part. We just divide by 3. Well, here we just get 5 over here, and we have this, left hand side, we have this scary thing. And this may look like a very hard problem because this dot 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 means we go on infinite because there's no end. You didn't really write down the end because this goes on forever. So it's actually, I do agree with you. It's very hard to work with infinite. I mean, think of it this way. If you're on infinite land, well, you can't possibly get off it because, well, if you add, subtract, multiply, or divide, infinite but anything, you still get infinite. I subtract 1 from infinite, I still get infinite. There's still infinitely different more square roots to go. How do we work with that? I mean, there is something we can do with infinite. That's just infinite minus infinite, but that's not very interesting either. Well, at least I know about how to deal with the square roots. First, to get rid of the square root, you just square. So we're going to square both sides to get rid of the square roots. Only one of these funky things go away. Infinitely different more square roots to go. Square this infinitely different many times. Now what? Hey, you know what? This taking the square root of x and then add on the square root of x. We already told that was 5. We already wrote that down. That's 5, so we can just substitute this in for 5. All this stuff, that's just 5. And we still have this add on x and the right hand side doesn't change. We didn't square anything. We just substitute in to 5 for all this, whatever this is. So we just subtract 5 from both sides. 20 here, and we get x is 20.